Okay, today we'll discuss about the clipper circuit. Before starting the circuit, first understand some basic related to the diode. We all know that if there is a silicon diode, the applied voltage between the anode and the cathode, if greater than 0.7 volt, the diode conduct as a short circuit, means that the current will be able to pass from node A to node B. But what happens when the voltage is less than 0.7 volt? Then the diode will not conduct the current and the diode will work as an open circuit between these two nodes. This basically help us to understand what the clipper circuit do and what is its uses. So first of all, let's say we have a circuit, like we have an input source and there is a diode, silicon diode, same as we have mentioned earlier, and there is a resistance. And what we want to do, we want to get the output from these two nodes corresponding to the voltage of the resistance. For input voltage, let's define a square curve with a voltage magnitude of positive 20 volt and then negative 20 volt. So when we apply this voltage in the diode, we can see that in the positive half cycle, the voltage difference between these two nodes is greater than 0.7 volt. Definitely. So when the voltage is greater than 0.7 volt, the diode will work as a short circuit. So for first cycle, means the positive cycle, we can see the original circuit will look like this. There is an input voltage and there is a voltage draw of 0.7 volt. The polarity will be this, because the circuit is drawing the current. For this, the diode will act as an opposite source and the resistance will be there. So if we apply now our voltage law, we can see that in the clock direction, minus input voltage and there is a plus 0.7 volt voltage drop, and this is the output voltage. The equation as usual described is the output is 0. Total output is sum up to 0. So solving this, there is the input voltage is plus 20 volt as we have seen earlier. So minus 20 plus 0.7 plus V output is equals to 0. So V output will be 19.3 volt. This will be corresponding to the first half cycle. First half cycle. In the second half cycle, let's say we'll work to this portion. So the voltage is negative 20 volt. So when we'll apply this voltage corresponding to this diode position, we can see there is a negative voltage which is less than minus 0.7 volt, which is actually minus 20 volt. So in this condition, our diode will not work and this is work as a open circuit. So the circuit will look like there is an input voltage obviously, and instead of the diode there will be an open circuit and there is a output range. So since there is no current passing through this resistance, the output voltage will be 0 for the second half cycle. Now if we have to draw the output curve, we can see that for the first positive cycle there is a voltage of 19.3 volt, but in the second half cycle the output voltage is 0. So we'll draw this voltage, and if we want to continue this cycle, we can see for this another cycle, since it's a pulse wave or square wave, there will be continuation, and then again we will get the positive cycle and again there is a 0 voltage and it will continue. So what we can see, this negative voltage is clipped back to 0 voltage, but the positive voltage is 19.3 volt. As it clips the negative voltage to a certain voltage, always the negative circle is clipped to the 0 volt. It is known as the clipper circuit, and we'll call this as a negative clipper. So if we want to find out what is positive clipper, we will reverse the direction of the diode and we can examine it will work as a positive clipper circuit. Now after exploring this all circuits, we will understand what is the biasing of a clipper. For example, let's discuss another circuit where we will add a biasing voltage of 2 volt, and there will, as usual, the diode. So this is our input voltage, there will be the resistance, and same way we'll capture the current and multiply it with the resistance to get the output voltage. So in this case, not only 0.7 volt is a problem for flowing the current, also there is a voltage of 2 volt which is acting in the reverse direction of the current flow. So if the input voltage is now greater than 0.7 volt plus this 2 volt, because this 2 volt is also resisting the current to flow in the same direction of the source, then we will get the diode is a short circuit, converted to the short circuit. But whenever the voltage is less than this 2.7 volts, our diode will not work. So for our this input, we are keeping the input same for proper understanding. It's a 20 volt input, and this is an minus 20 volt. For the first positive cycle, if our voltage is not greater than 2.7, this will not work. But if as our input is greater than 20 volt, so our circuit will look like this circuit. So there is a plus 2 volt drop, and there is a 0.7 volt. So 2 plus 0.7, and the resistance which is working as an output. So it's an input. If we draw the current equation here, V input plus 2, 0.7 plus V output is equals to 0 volt. So solving this, the value of minus 20 plus 2.7 plus V output, our output voltage will equals to 17.3 volt. But what happens if we use the negative cycle, which we are interested now? For the negative cycle, the reverse voltage appearing across this diode is not only 20 but also this 2 volt, because the both portion is connected to the negative portion, so that the diode will never work in the negative cycle. So same the previous case, output for second cycle will be 0. So now if we draw the curve, we can see this will look like this. For the positive cycle, there will be an output of 17.3 volt, and for the negative cycle there will be no current, and it will continue. So this is also an example of positive clipper. Next section we will discuss about the clamper circuit.